Good afternoon, students. In the today's lesson, we are going to understand TypeScript interfaces, inheritance and modules. If you recollect the last class, we have seen what is TypeScript and why we have to go for the TypeScript. What is TypeScript? TypeScript is an extensive language of JavaScript. That means, what are the features we have in JavaScript, same features we are going to continue in the TypeScript. In addition to that, TypeScript provides some additional features. What are the main topics of TypeScript? Class based object oriented programming, interfaces, inheritance and modules are the main important topics of the TypeScript. So, in the last class we have seen how to work with the TypeScript, that means how to create a simple program in TypeScript, how to compile it, how to execute it and also how to work with the classes and objects of TypeScript. Coming to the today's lesson, we are going to understand about the interfaces, modules and the inheritance. So, first let me explain about the inheritance. Inheritance is one of the important object oriented programming feature. Inheritance means the process of creating a class based on another class, the process of extending the existing class by creating a new class, the process of copying all the members of the parent into the child class. Here we have to use two types of classes, parent class and the child class. The parent class contains some properties and methods. These properties and methods of the parent will be automatically carried forwarded to the child class. For example, we have class A and class B. Class A has two members A, B, C and X, Y, Z. The class B by default contains these members. In addition to those two members, the class B can have additional extra properties and extra methods. So, what are the existing properties methods we have in class A will be automatically carried forwarded to the class B, because class A is a parent, class B is a child. All the members of parent will be automatically given to the child. Additionally, some extra members can be added. So, in case if you create an object for the parent class, only the parent properties, parent methods can be accessible. If you create object for the child class, we can access the parent members and child members. So, the same child class object is able to access both the members. So, in that way it is a concept of reusability also, like we are going to reuse the parent members in the child. Instead of declaring the same members in parent and child manually, if you can follow inheritance, the parent members will be automatically carried forward to the child. Let us try to understand how to create the parent child relationship among the classes by using inheritance concept in TypeScript language. Let us see the syntaxes. So, syntax of inheritance in TypeScript. The first step is create a parent class, parent class name. So, in the parent class we need not follow any special syntax. The normal regular syntax is quite enough for us. Class name is quite enough for us. We are going to create a child class. So, class child class name. This child class should be the child of the corresponding parent. I want to specify that this is a parent, this is a child, but as of now both are individual classes, nothing is parent, nothing is child as of now. A predefined an existing parent class, that is a parent class here. So, if you create object for the parent class, only the parent members are accessible. If you create object for the child class, we can access both members, parent and child. Now, let us try to understand how to create object for the parent class. Create object for parent class. New parent class. As we know already, the new keyword is used to create an object for the parent class, followed by the parent class name we have to provide, but this part will create an object for the class. That means, an empty memory allocation will be allocated based on the existence of the parent class. What are the properties methods we have declared in the parent class, those properties methods will be exist in the object. Now, we have to store this object reference inside a variable that is called reference variable. This variable is going to be the reference of this particular object, because this variable consists of some address that points to the particular object. Variable makes it easy to access the object. Object only contains real properties and methods. Variable does not contain the properties and methods, but how do we access them? Through object. For example, you want to access your TV through remote. If you want to change your channel, you need not touch your TV, through the remote we can operate. So, the variable is like a remote using which you can access your object. We have to store the address of this object inside a reference variable. So, where reference variable name is equal to new parent class name, but using this particular reference variable we can access this object, and through that object we are able to access only the parent member. Here parent member means either parent property or parent method, but if you create object for the child class, we can access both members. See, we are going to create an object for child class, then through that reference variable we can access parent member as well as child member too. So, we are able to access the parent member and the child member through the same reference variable, because this reference variable holds an object of the child class. So, the fundamental rule of the child class is that it is eligible to access the parent members too. It is the right of the child class object. So, let me show a practical example how do we apply the inheritance in the real world. So, let me take an example of person versus student. Here person is a parent class, student is a child class, because every student is a person, but every person is not a student. So, person is a parent, student is a child. How do we represent this one? We have to create a class called person. Here person is the name of the class. It is recommended to start the class name with uppercase, and we have let's save this file name inheritance.ts. We have to save it in C drive, TypeScript folder, file name inheritance.ts. Now, we are going to create person name string data type, age number data type, because every person is having a name and as well as age. So, let us say class student. I want to say the student is declared or created based on person. So, we can say extends person, which means that student is a child, person is a parent. So, the class syntax that we have to follow for declaration of inheritance: class, child class name, extends the parent class name. Now, inside this we are going to create the child class properties. For example, student ID and marks. Here student ID number, marks are the specific properties that are applicable for only student. These are not applicable for the person. So, whenever the detail are common for all the types of persons, including student, employee, for all types of members, we have to declare those members inside the person parent class. Whenever the details are specific to only student, that details must be provided for the in the student child class name. For example, you want to store the name of the college or the name of the university, something. So, that is applicable only for the student, right? So, we have to declare in the student class, but you want to store the date of birth every person has their own date of birth. So, date of birth is common for all types of persons, not only for student. So, we have to store the date of birth inside a person class. Now, let me create an object for the person class. The new keyword is used to create an object for some class, not only for parent, but also for any class. Here we have to provide name of the parent class. That means we are going to create a new object for which class? Person class, that is a parent class. But what is the rule here? The parent class object can access only the members of the parent, that is person name and age only. We have to store its reference inside a variable called some p, for example, p for person. Now, we can access only we can access the person name and age. We cannot access the other student ID and marks, because the parent class object can access only the parent class members. So, we can either set value, we can do anything like this. Now, I would like to display the value p dot person name, p dot age. Right. Now, we are going to compile and execute this program. How do we compile? We have to open your command prompt window. CD means change directory to a specific folder called TypeScript. You can also create your folder in D drive or E drive, any drive, not a problem, but I recommend you to create in C drive because it will be easy to access. So, CD :TypeScript will make you enter into TypeScript folder. Now, inside that we have to provide the command called tsc file name, that is inheritance.ts. So, we are going to compile this particular program and also we are going to execute it by giving the command node followed by the file name .js. Remember, while compilation we have to give .ts. While the compilation itself, the program is going to be compiling converted into JavaScript file. So, that means automatically the inheritance.js has been generated. If it is already exists, it will be overwritten automatically. So, at the time of execution, we have to provide node followed by the file name .js, not ts. As of now, we can see the person name and age respectively is Scott and 20. Now, we are able to demonstrate how do we create object for the child. What is the benefit here? If you create object for the child, we can access the parent members as usual plus child members too. As the object is created for student, we can access the child class members, the student ID and marks. As the extends person is given, we can access the parent members too. So, we are saying s dot, see we can access the parent and child members. For example, student ID is equal to 102, 101, marks is equal to 80. Okay, we are printing the student ID and marks. In the middle, I am just printing the separator line for understanding. Right, let us compile and run this. So, hey TSC, please compile my file. So, TSC inheritance.ts. So, it will internally read this particular file and convert the same into respective JavaScript file. Let us execute this. Now, we can see the parent object contains only the parent members, but child class object may contain the child members plus parent members also. So, this is what we call it as the inheritance. So, we have understood the inheritance topic. Next, let us try to understand the next topic, that is interfaces. What is interface? Interface looks like a class, but not a class. Interface basically contains the list of properties and methods that you are going to create inside a class. what list of properties and methods that you are going to write inside the class, that list only present inside the interface. For example, I plan a class that contains some properties and methods like the employee registration ID, employee name, and designation. These are the list of properties that I wanted to have. So, since I definitely decided to write these particular properties, I can first fix them. I have to specify these particular list of properties and methods inside an interface. So, first we have to create an interface. Based on an interface, we have to create the class. Interface does not provide any reusable properties and methods, but interface mainly represents the rules for writing the classes. So, this class must and should contain a set of properties and methods. So, that is the main intention of the interface. Interface restricts, specifies that these are the list of properties, methods that you are going to have in my class, in your class, in every class. This particular set of properties and methods I want to definitely have. So, the list of properties, methods that you are going to write inside the class can be decided or declared by the interfaces. For example, you created an interface expecting we are receiving two numbers, that is A and B. We are going to perform addition and subtraction. So, add is a method here, subtract is another method. So, two properties, that is A and B, plus two methods, that is add and subtract. So, with these properties and methods, you have to create an interface. That means, it is your expectation. So, I want these particular properties. So, it is my responsibility to implement it. It is just like a for the textbook index. Index is available in the beginning of the book, which contain the list of chapters. So, that means, we are expecting these particular list of things. So, that you have to implement it. That is why first we have to create an interface. Based on the interface, we are going to create a set of classes, one or more classes. What are the properties, methods declared in the interface that must be present in the class. So, let us understand how to work with the interface practically. So, interface development. First, step number 1, we have to create an interface. In order to create an interface, we should write interface followed by interface name, which specifies that this is the name of the interface, and we have to specify that it is an interface, because other people may think that it is a class. So, we have to clearly specify that we are going to create an interface, then followed by we have to provide the name of the interface, and then we have to create a class based on interface. The point is the class extends interface, or you can say implements interface. Class name implements interface name. Interface incorporates the business rules. What list of properties, methods you are going to have inside the class that you must define in the interface. Interface is like giving a promise. These are the list of properties and methods that you are going to write. In another perspective, the interface is like a rule. The compulsory these class must be having these particular properties and methods. The rules, or you can say the representation or promise can be given by the interface. So, inside the interface we can declare the property like this: property name, data type, method, arguments, then corresponding data type. We can create any number of arguments, then followed by a return type. So, every property must be of a specific data type. What type of value you wanted to write here, that you can write. For example, you can give like number, string, boolean, anything like that. And so, with this the interface is ready, we have to write the actual implementation of the same. So, the same properties and methods can be declared here with the actual code. Actually, property declaration and definition syntax is same, but method declaration above, method implementation here. So, what function body you would like to write for the methods that can be written in the class, but not in the interface. Interface contains only the method declaration, but class contains the method implementation with actual code. Then we have to create object for the class. So, where reference variable is equal to new class name, then reference variable dot we can access like property as well as method. So, we can create an object for the class, then we are able to access the we are able to store its reference inside a reference variable, then we can access its property and method. So, this is the way how to work with the interfaces. Okay, so first step we have to create interface, then we have to create a class based on interface. The class implements interface, this syntax specifies the same point, and we have to create object for the class, then we can call the corresponding properties and methods. And this class may contain some additional properties and methods that are not exist in the interface. But what are the properties method declared in the interface that must be implemented in the class, otherwise the class cannot be compiled. Right. Now, let us try to create a simple program for the interfaces. Interface name, this is the syntax. So, let us do one thing, let us implement student ID and marks. Student ID and marks. Interfaces dot ts. Right. So, I would like to stress and specify that this class must and should contain the student ID and marks. How do we specify the same point? Interface I student. Here the interface name starts with I, it is recommended to start the interface name starts with I, and here we have to declare the same properties and methods what you are going to have inside a class. So, first remember the point, interface first, class next. First the interface specifies that I need a class, at least one or more classes that contains these particular properties, that is student ID and marks. Now, the class answers yes, I am present, I am containing the student ID and marks, but this class does not belong to this particular interface, there is no relation, and if you delete some member like this, it is not an error. But it is recommended to specify that I am going to follow the rules and regulations provided by the interface. That means, these properties and methods I am going to implement here. To specify that, we have to say implements followed by the interface name. Then the system will check, okay, what are the properties and methods of the interface, are they implemented in the class, it will check. If yes, there is no any problem, the program will compile and execute, and if it is not, in case of any spelling mismatch or data type mismatch or any other reason, the program cannot be compiled, cannot be executed. Have a look once, TSC interfaces dot ts, that means compilation, then node interfaces.js. So, we are able to see the student roll number and marks. Okay, that is fine. So, what happens when you do not declare a property, for example, student ID? So, in such cases, near the class student, you will get error saying that this student class does not follow the rules and regulations of interface. That means, the interface specifies that okay, these two properties must be exist, but the class is not following the same. So, that is the rule that we have to follow. So, let me bring back the student ID. Okay, that is fine. Now, we can implement the methods also. Let me show an example of interface methods. For example, add is the name of the method. Now, get result is the name of the method. Return type is string. That means I would like to return either pass or fail. I want to say whether the student is pass or fail based on the marks. So, here we have to implement the method with the same name with the same logic. If the marks is less than greater than or equal to 35, then we can return pass, otherwise fail. Okay. So, we have written a code such that if the student marks is less than or greater than or equal to 35, then the student result is pass, otherwise fail. Right. Let me compile and execute TSC. What could be the file name? Interfaces.ts, then followed by node interfaces.js. So, we are getting the same point. Okay, because we have forgot to call the method get result. Okay, again compile and execute. Okay, now we are able to see the student result is pass. Here the method is declared in the interface, but implemented in the class. So, that is what I am saying, the class implements, the interface decides or declares. This is all about the interfaces. Now, next topic, let us understand about modules. What is module? A module is a file, a individual TS file. For example, file1.ts, it is a file, it is a module. File2.ts, file3.ts. Every individual TypeScript file is nothing but a module here. A module may contains a set of classes, interfaces. So, some list of classes and interfaces can be present inside a module. For example, there is a file1 which contains the student class, but in a project it is very common to access this class in another file. For example, the student class present in the file1, but I want to access the same in file2. I want to create object in the file2, but the class present in the file1. So, how do we share the classes among the multiple files? So, by default, whatever the classes interfaces declared inside a class can be accessible, whatever the classes and interfaces can be declared in the file can be accessible in the same file. Suppose the class 1, class 2, 10 classes created in the file 1. We can access the class 1 to 10 in the same file only, but not in another file. But I want to really access. If that is the case, we have to go for something called modules concept. First, we have to assume the first one as a first module, second file as a second module. For example, let us say source module and destination module. The source module exposes the class 1. The second module, that is a destination module, receives or attracts or imports the class 1. So, exposing, giving is called as exporting. Receiving and utilizing is called as importing. So, if I am the source, you will be the destination. The source has to export, the destination has to import. So, in order to export, we have to use export keyword. In order to import, on the other hand, we have to use import keyword. Export in source module, import in the destination module works fine. Let's try to understand practically. So, we are going to create the classes, the interface in one file, the class in the second file, and the corresponding client code in the third file. Let's do it. Let's call it as file 1, otherwise module 1, module 2, module 3. Module 1 contains an interface. Module 2 contains a class. Module 3 specifies new class B. So, here we have to export class A to module 2, class B to module 3. If you do not do that, what happens? The interface A by default accessible in the module 1 only. If you export here, then only we can import there, then only the class A is identified in the module 2, otherwise not. So, first we must export here. And here we have to import. Again, here we have to export. Here we have to import, and so on. It does not mean that only one export requires one import. One time export, any number of time imports. Okay, let us understand the same practically. So, we are going to create a file module 1.ts. We are going to save it in C:\typescript folder. So, we are declaring an interface. Okay. But I want to make this interface accessible to other files, other modules. Then what can we do? This interface must be declared as export. The export keyword specifies that, hey, this particular interface can be accessible in other files. For example, module 2 or module 3 can be able to access any module. Basically, any module can access this particular interface. That is the meaning of export. Let me save this. Right. Now, let us try to understand the second file, that is module 2, module 2.ts. In this, let us place this class. But hey, this particular I student is unknown because by default it is searching for I student inside the same module only. It is not checking in other files. That is the reason, as I student definition is not present in the same file, that is module 2, it is showing me error. But I have to say, I have to import which one, I student, from which file, module 1. So, then automatically it will go and check the module 1.ts. So, okay, we have to provide dot slash. Okay, it will go and check the module 1. In the module 1, the I student will be retrieved or loaded, then only the file is accessible. Now, we can check here dot slash represents that current working folder. The present working folder, the current working folder is represented as dot slash, which means that by default it refers to C:\typescript. This particular folder, this current working folder is represented as dot slash. Inside the current working folder, which file you want to access, that is module 1. So, module 1 is trying to access here. From this particular file, there may be so many exports. In the same file, you may export multiple things. For example, you can export one interface, one class, and one other, maybe variable array, whatever. So, but we are exporting a particular interface called iStudent, only that I want to import. So, here we have to specify the name of the interface. Okay, now we are getting this interface from this so and so file. That means this interface is available to the current working file. Till end of this file, anywhere we are able to access the interface, right. But it does not mean that the same importing works for other file. In other file, if you want to import, we have to import once again explicitly. But importing, remember, importing is applicable only for the same file. Export works for all the files, import only for single file. Let me create module 3. Let me create a new file called module 3.ts. Let me write this particular remaining code. The code for creating object and calling the properties and methods, but what is the student ID, from where it is coming, I do not know. The reason module 3.ts does not contain the definition of the student. So, it is unable to find the student, but where is the student class available? In the module 2. So, that means this class must be exposed or exported to other files. Export, this keyword applicable for only for all the files, but import must be done independently for every file. For example, you want to use the student class in 10 files. In each file independently, we have to import the student class. From which file? Module 2. That means this student class is available till end of the program. So, in the same file, wherever you wish, you will be able to access the student class. Now, let us compile and execute. Node module 3.ts. Okay. Let me compile first. TSC module 1.ts. First we have to compile, and then we have to compile module 2.ts, and then we have to compile module 3.ts. So, first we have to compile in the order. So, first module 1.ts we have to compile, and then module 2, and then module 3. If you do not compile the module 1 and attempt to compile the module 2 unable to find what is module 1, that is why this statement will be error. That is the reason first module 1, that means the source module must be first compiled, and then the destination module. Then module 3 should be compiled after compilation of the module 2. Okay, let me execute node module 3. Now, we are able to understand the output is displayed, that is the student ID, marks, and result. So, the same output as the previous program, but the difference is this is perfect for real time applications, because in real time you never want to have the same single file. In real time applications, what happens is you will be writing so many files. For example, the file 1 contains one class, file 2 contains another class. So, you want to write every interface, every class in individual files. At that time, this module concept will be very much important and very much useful. So, the best practice in real time is that every class must be declared in individual files. For example, the class 1 in class 1.ts, class 2 in class 2.ts. Generally, usually the class name and interface name will be usually same. So, we have to import the particular interface or particular class from so and so particular the file. So, let us try to see the same program how to give the same class name as a file name. Okay, let us try to give here. Here we have an interface, that is iStudent. the iStudent must be a name of the file itself. So, let me close these files. Let us rename these files. Okay, let me delete these .js files also, we do not want them. This module 1.ts contain the definition for iStudent, right. So, we have given the file name, that is iStudent.ts. Next, we are going to have the other file, that is student.ts. Module 3 contains some student details.ts. So, we are having 3 files, iStudent.ts, student.ts and student details.ts, 3 files. But when you open these particular files, we are getting errors because the file names are wrong, right. So, first iStudent.ts contains an interface saying that iStudent. Next, student.ts has to import the interface, that is iStudent, from the so and so file, which file module 1 is no more exist. So, the file is iStudent.ts. .ts will be taken automatically. So, we need not mention the file extension here. So, from so and so file, so and so interface we are trying to import. So, based on this location, it will go to the particular file first. Inside the particular file, the particular interface exists or not, then it will check whether it is exported or not. If all these conditions are true, this works fine. Same rule applicable for the other one also. So, the module 2 does not exist, but we have student.ts. So, it will go to the particular file, that is student.ts. Inside that, the particular student class exists or not will be checked, and then if it is exported or not, it is checking. See, if all these conditions are true, then it works, otherwise it will be error. Now, let us compile all these files. First, which file should be compiled? iStudent.ts, and then we have to compile student.ts, and then we have to compile student details.ts. So, 3 files, iStudent.ts, student.ts, student details.ts. 3 files must be compiled first in a same sequence. If we change the sequence of compilation, it may not execute. So, then we have to finally execute only the student details.ts. Well, we are getting some error. Yeah, so JS, we have to execute JS. Okay, now we are getting the corresponding output. Okay, that this works fine. So, the point is that first we have to compile the source module, then only we can compile the destination module, and then finally we can execute the destination module 2. Okay. So, today we have mainly understand about the interfaces, inheritance and modules. Inheritance is a concept of creating parent-child relationship among the classes. The parent class has some properties and methods. The child class can access the same properties, same methods. We have to create the inheritance by using extends keyword. Then the interfaces contain the list of properties and methods that you are willing to have in the class, and the modules contain the list of the one or more classes. The module can export a class or interface. The source module exports, the destination module imports. This is what we have understood in the today's lesson. So, thank you, and we will meet in the next lesson.